We're standing right on the edge of the unknown. In this explainer, we're going to map out the incredible frontiers humanity's pushing past in the year 2026. I mean, from the deepest unsolved mysteries of the dark cosmos to the invisible building blocks of our reality, we are desperately searching for answers.
So, what do a Jupiter space probe, global carbon emissions, and the future of encyclopedias actually have in common? It sounds like a setup to a joke, right? But honestly, these are the critical battlegrounds of 2026. These are the literal frontiers where established facts clash with the absolute unknown, and where we're racing to decode the sheer complexity of our world.
Here is our roadmap for today's explainer. We'll be looking at unlocking the universe, the global energy transition, investing in medical breakthroughs, the future of knowledge, and finally, securing our digital world.
Let's start with Section 1, Unlocking the Universe, pushing the boundaries of space and particle physics. The European Space Agency has an absolutely relentless schedule for 2026. In June, the Euclid Galactic Bulge Survey drops interim data, essentially mapping out the large-scale structure of the universe to hunt for those massive cosmic mysteries, dark energy and dark matter. Then in September, the JUICE mission harnesses Earth's gravity, slingshotting its way toward Jupiter to check out its icy moons. Could their hidden oceans actually harbor the origins of life? And in Q4, the Hera spacecraft arrives at asteroid Dimorphos to inspect a kinetic impact. That is literally turning planetary defense from science fiction into established scientific fact.
But to solve the mysteries of the microuniverse, we have to talk about the massive financial scale of CERN's Future Circular Collider, or the FCCEE. This is proposed as humanity's next flagship collider. By smashing particles together at unprecedented energy levels, well beyond 10 tera-electron volts, physicists are hoping to finally crack the code of the Higgs boson and understand our physical reality. But of course, a project of this magnitude requires decades of operation and billions of Swiss francs.
Now, because of those immense costs, there's a scaled-down, or de-scoped, alternative on the table. By reducing the number of particle collision points from 4 down to 2 and lowering the radiation power, CERN could save over 1.2 billion Swiss francs, which is huge. But there's a massive scientific trade-off here. It's going to take roughly 21 years of operation, instead of just 15, to generate the exact same amount of universe-unlocking data.
Yet, even with these painful budget cuts, scientists are absolutely adamant about one thing. The high-energy top quark run is essential. It's a deal-breaker. Without it, our ability to discover new physics is completely crippled. So researchers are urging that this stage absolutely must happen eventually. It might get delayed until year 23 to absorb that cumulative budget deficit, but they want to ensure we definitely don't abandon the ultimate quest for cosmic knowledge.
Moving on to Section 2, the global energy transition, balancing rising electricity demand with carbon emissions.
Bringing it back down to Earth, we're currently witnessing a global tug-of-war. On one side, we have these massive power-hungry drivers, huge data centers, the rapid rise of electric vehicles, and extreme weather completely forcing up air conditioning use everywhere. But pulling in the exact opposite direction is the rapid expansion of clean energy, things like wind, solar, nuclear, and battery storage. So the great mystery of our modern economy right now is whether renewable growth is actually expanding fast enough to offset this surging demand.
If you're running a business in 2026, these are the exact practical questions you have to be asking to survive the shift. Is regional electricity demand rising faster than you expected? Are emissions falling because of a true structural change, or is it just a temporary weather pattern? Are renewables expanding fast enough for your own operations? What's your exposure to fossil fuel price volatility? And what policy changes are going to hit future emissions targets? Answering these is exactly what separates established trends from dangerous short-term speculation.
Next up, Section 3, Investing Medical Breakthroughs, Funding the Future of Healthcare.
$47.2 billion. It's a staggering number, isn't it? That massive figure is the 2026 budget for the National Institutes of Health. It's basically the bedrock for solving the deepest mysteries of the human body, funding the ongoing war against cancer, and driving the absolute next generation of cardiovascular care.
But this goes way beyond biology. Medical research isn't just saving lives. It's literally a foundational engine for local economic growth. To put it into perspective, every single dollar invested in NIH research generates approximately $2.56 in local economic activity. It supports jobs, local businesses, and it moves these incredible discoveries from the laboratory bench directly to the patient's bedside.
Because of this, medical professionals are actively pushing Congress.
There's a clear call to action right now from groups like the American Medical Association for lawmakers to increase the NIH budget for fiscal year 2027. Their argument is pretty straightforward. Sustained, meaningful funding increases are absolutely essential if America is going to maintain its research leadership and actually keep pace with the mysteries of modern medicine.
All right, Section 4, The Future of Knowledge. Evolution of encyclopedias and scientific publishing.
While Wikipedia obviously remains a giant, ongoing concerns over systemic bias have sparked a whole new era of specialized knowledge vaults. For instance, in 2026, we're seeing platforms like Justipedia focusing heavily on free speech and minimal censorship. Then there's HandWiki. This one is science-focused with over 2 million entries, and get this, it requires verified professional credentials just to edit. Citizendium relies on real name registration and strict peer review. And MDWiki provides specialized medical tables specifically designed for offline access in remote areas. We're essentially building heavily guarded fortresses to protect established facts.
And speaking of protecting facts, the integrity of new knowledge is facing a totally different kind of threat. To protect scientific publishing, journals are now rolling out mandatory artificial intelligence declarations. Authors basically have 3 strict options. They must declare no generative AI tools were used at all, or declare AI was only used for basic language editing and grammar, or clearly describe exactly how and why AI tools actually influence the scientific content. In the search for truth, absolute transparency isn't just nice to have anymore, it's the ultimate requirement.
Finally, Section 5, Securing our digital world, protecting information in a post-quantum era.
We are rapidly approaching the day when our current digital encryption is rendered completely obsolete. Frameworks like SafeCipher's 2026 Post-Quantum Cryptography Readiness Checklist provide the playbook to defend data against future quantum computing attacks. And honestly, this isn't optional anymore. Organizations are literally scrambling right now to build new cryptographic defenses today so their highly sensitive data cannot be easily shattered by the superpowered quantum computers of tomorrow. Think about it. It's a technological race against a capability that doesn't even fully exist yet. So, as we map the dark universe, hunt for the origins of life on icy moons, and rewrite the rules of energy, AI, and quantum data, looking at all these incredible advancements side by side leaves us with one thrilling question. As these frontiers expand and our search for answers accelerates, are we truly ready for the mysteries we'll uncover next? Keep learning, and I'll see you in the next explainer.